Let us look at proposition number 3 of book 13 of Euclid's Elements. The proposition says, if a straight line is cut in extreme and mean ratio, then the square on the sum of the lesser segment and the half of the greater segment is 5 times the square on the half of the greater segment. Let's see what this means and how to prove it. Given a straight line AB, cut AB at C in the extreme and mean ratio. Let AC be greater than BC. Bisect AC at D. Then what the proposition is saying is that BC plus half AC, the whole square, is equal to 5 times half of AC square. So if you see BC plus half AC, BC plus half AC is BD. So BD square is equal to 5 times half of the square on AC, that is CD. So what we have to prove is that BD square is equal to 5 times CD square. Let's proceed. Describe the square on AB. Let's mark these points, W and E. Now let's join B and W. Now let's draw a line parallel to AW from D to L. Similarly, draw a line parallel to AW from C to S. Mark the intersection of BW, the diagonal, and DL as K. And similarly, mark the intersection of BW and CS as U. Now draw a line through K parallel to WE. Let's mark these points as H and N. Again, draw a line through U parallel to WE. And let's mark this as R and M. Mark the intersection of RM and DL as G. And similarly, mark the intersection of HN and CS as F. And finally, let's mark the gnomon OPQ. So now AC is equal to 2 times CD. Why? Because we bisected AC at D. So AC is 2 times CD. Let's square both the sides. So AC square is equal to 4 times CD square. Now, AC square is what? Is RS. And CD square is what? CD square is FG. So that means we can say RS is equal to 4 times FG. Rectangle AB by BC is equal to AC square. AB by BC is equal to the square on AC. That is our extreme and mean ratio, because that is how we cut the straight line AB. Now, rectangle AB by BC is equal to C. How? AB by BC. But AB is equal to BE. So BE by BC is nothing but CE. So we can say AB by BC equal to C. So C is equal to RS. How did we get this? Because AB by BC is AC square. AB by BC is C. AC square is what? AC square is RS. And AB by BC is C. So C equal to RS. So that means C is also equal to 4 times FG. Since AD is equal to DC, AD equal to DC implies that HK is equal to KF. So that means the square on them will also be equal. That is HK square is equal to KF square. Now HK square is what? Is HL. And kf square is what? Is gf. So gf is equal to hl. Now since gf is equal to hl, that means this, and they are squares, that means gk is equal to kl. Mn is equal to ne. That means mf is also equal to ns. Parallelograms between the same parallel lines and equal bases are equal to each other. Since mf is equal to cg, that means fe is also equal to cg. Now let's add cn to both the sides. So we have fe plus cn is equal to cg plus cn. Now fe plus cn is what? Fe plus cn is ce, and cg plus cn is the gnomon OPQ. So gnomon OPQ is equal to 4 times Fg, because Ce is equal to 4 times Fg. Let's add Fg to both the sides. So we have gnomon OPQ plus Fg is equal to 4 times Fg plus Fg is 5 times Fg. Gnomon OPQ plus Fg is what? Is Dn. So Dn is equal to 5 times Fg. And Dn is what? Dn is the square on BD. So BD square is equal to 5 times Fg is what? Is the square on CD. So we have proved that BD square is equal to 5 times CD square, or we have proved that BC plus half of AC the whole square is equal to 5 times half of AC square. That is proposition number 3 of book 13 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.